What if there are civilizations out there, intelligent, curious, wondering if they're alone, who will never see the stars? What if they live beneath kilometers of ice, under oceans so deep that the sky is a myth? What if some minds in this universe are imprisoned by their own worlds? Welcome. We're glad you're here with us tonight. You're listening to this in darkness, or near darkness. Maybe you're resting, maybe studying, maybe just letting your thoughts drift. However you've arrived, you're welcome to stay as long as you like. Before we go further, if you enjoy these quiet explorations of space, a like or subscribe would really help this channel grow. But no pressure, we'll be here either way. Tonight, we're going somewhere cold, somewhere far from here. Let's imagine standing on the surface of Europa, one of Jupiter's moons. You're wearing a suit, of course. You'd have to. The temperature here is around minus 160 degrees Celsius, cold enough that the air you breathe would freeze solid before it left your mouth. But let's say you could stand there safely and you look around. The ground beneath you isn't rock, it's ice. Not the ice we know from winter sidewalks or frozen ponds. This is ice on a scale that's hard to picture. The shell of ice covering Europa is somewhere between 15 and 25 kilometers thick. That's not a frozen lake, that's a frozen world. Above you, Jupiter hangs in the black sky, enormous and silent. It doesn't twinkle, it doesn't move, it just exists, a massive banded giant filling half the sky, casting a faint cold light across the ice plains. And below you, far below, there's an ocean. We know it's there, not from guessing, but from measurement, from magnetic fields and the way Europa wobbles as it orbits. Beneath those kilometers of ice there is liquid water, an ocean that covers the entire moon, an ocean that may be 100 kilometers deep in places, maybe more. Europa isn't alone in this. Enceladus, one of Saturn's moons, has an ocean too. So does Ganymede, possibly Titan, though Titan's ocean might be mixed with ammonia, strange and caustic. And there may be others we haven't confirmed yet. Mimas, Triton, even distant Pluto might hide seas beneath their frozen surfaces. These are the ocean worlds, and they make us reconsider what we mean when we talk about habitable places in the universe. Because here's the thing we're beginning to understand. You don't need sunlight to have an ocean. You don't need to be in the Goldilocks zone, that narrow band around a star where water stays liquid. You just need heat from below and insulation from above. These moons are heated by something we didn't expect, something invisible, something that changes everything we thought we knew about where life could exist. And if life is there, it has never seen a star. Not once, not ever. Let's think about darkness for a moment. When we say these ocean worlds exist in darkness, we're speaking from our perspective. We're creatures who evolved under a sun. Our entire biology is built around light. Our eyes, our circadian rhythms, our crops, our moods. Even our language, we say I see when we mean I understand. Light for us means information, safety, life itself. But darkness doesn't mean the same thing everywhere. Consider our own planet's deep oceans. Below about 200 meters, sunlight doesn't penetrate anymore. This is called the aphotic zone, the place without light. And it makes up about 90% of the ocean's volume. Most of the water on Earth exists in complete darkness, and yet it's full of life. Not just microbial life, though there's plenty of that. We're talking about fish, squid, jellies, crustaceans, complex creatures with nervous systems, behaviours, even what we might call personalities. They've never seen the sun, they never will, and they don't miss it, because they never knew it existed. Some of them make their own light. Bioluminescence, anglerfish with their glowing lures, jellyfish that pulse with blue-green light, squid that can make their entire bodies glow and then go dark in an instant, like living fireworks. But this light isn't like sunlight. It's not constant. It's not ambient. It's communication. It's camouflage. It's hunting. It's conversation in a language of flashes and glows. Others don't use light at all. They navigate by touch, by electrical fields, by chemical traces in the water. Some fish can sense the heartbeat of prey buried in sand. Some can feel the movement of water displaced by something swimming meters away. In other words, they have rich, complex sensory lives. Just not visual ones, not in the way we understand vision. So when we imagine life in the oceans of Europa or Enceladus, we shouldn't think of it as living in deprivation. We should think of it as living in a different kind of richness. What if darkness for them is home? Not a condition to overcome, but simply the nature of existence. There's something profound in that shift of perspective. We assume that intelligent life would want to see the stars, would need to see them, because we do. But what if that's just us projecting our own desires onto the universe? What if there are minds out there, complex, curious, intelligent minds, who live in a world where the concept of seeing means something entirely different? Where far away isn't measured in light years but in pressure gradients and temperature zones, where up and down matter more than any horizontal direction, because you're living in a three-dimensional ocean that extends from the rocky core below to the ice ceiling above. We've spent centuries imagining aliens who look up at the stars like we do, who build telescopes, who wonder about the cosmos, who reach for the heavens. But what about the ones who can't? Not because they lack curiosity or intelligence, but because their world simply doesn't offer that possibility. They might have philosophy, mathematics, art, culture, everything we associate with consciousness and meaning. They might wonder deeply about existence, about whether they're alone, about what lies beyond the boundaries of their experience. But those boundaries are ice, kilometers of it. And beyond that ice, though they can't know this, there's vacuum, there's radiation, there's Jupiter, crushing them with tidal forces that keep their ocean liquid. There's a universe full of galaxies and stars and light, and they will never ever see it. Is that tragic, or is it just different? We'll sit with that question, because the answer depends on whether we believe seeing the stars is necessary for a meaningful existence. And maybe it isn't. Maybe meaning is something each form of consciousness creates for itself, within whatever boundaries it's given. Maybe darkness can be home, truly home. So we've talked about the ice above and the darkness within. Now let's talk about what keeps these oceans liquid in the first place. Because this is where the story gets strange and beautiful. Europa orbits Jupiter at a distance of about 670,000 kilometers. That's fairly close in astronomical terms, but it's still far enough that sunlight arriving there is weak, about 25 times weaker than what we receive on Earth. Not nearly enough to melt ice, not even close. And yet, beneath that frozen shell, there's an ocean. Liquid water, possibly warm water. The heat doesn't come from above, it comes from within, and it comes from something we don't usually think of as a source of warmth, gravity. Let's walk through this slowly, because it's one of the most elegant processes in the solar system. Europa doesn't orbit Jupiter alone. It shares space with 3 other large moons, Io, Ganymede, and Callisto. And they're all pulling on each other gravitationally as they orbit. This creates something called orbital resonance. For every one orbit Ganymede makes, Europa makes 2. For every one orbit Europa makes, Io makes 2. They're locked in a dance, a mathematical rhythm that's been going on for billions of years. Now here's what matters. Because of this resonance, Europa's orbit isn't perfectly circular, it's slightly elliptical, which means that as Europa goes around Jupiter, sometimes it's a little closer, sometimes a little farther away. And Jupiter is massive, so massive that its gravitational pull changes noticeably over those distances. When Europa is closer to Jupiter, it gets squeezed. The entire moon compresses slightly under the immense tidal forces. When it's farther away, it relaxes, expands back out. Closer, squeeze. Farther, release. Squeeze. Release. Over and over. This is called tidal flexing. And flexing generates heat. Think about bending a paperclip back and forth. At first, it's fine, but keep bending it, and the metal gets warm at the stress point. Eventually it might even glow. That's friction at the molecular level, energy being converted to heat. Now imagine that happening to an entire moon. Not dramatically, not violently, but constantly, relentlessly. Billions of years of gentle squeezing and releasing. The ice flexes, the rocky core flexes, and where there's flexing, there's friction. Where there's friction, there's heat. Enough heat to melt ice. Enough heat to maintain an ocean. Possibly even enough heat to drive hydrothermal vents on the ocean floor. Places where superheated, mineral-rich water pours out of cracks in the rock. We know these vents exist on Earth. We've visited them. And around them, in the crushing darkness of our deepest oceans, we've found ecosystems that don't depend on sunlight at all. Instead of photosynthesis, they use chemosynthesis. Bacteria that can extract energy from chemicals like hydrogen sulfide, and then other creatures eat those bacteria, and other creatures eat those creatures. An entire food chain built on chemistry instead of light. If hydrothermal vents exist on Europa, and there's good reason to think they might, then the same process could happen there. Life powered not by a sun, but by the heat of a moon being squeezed by its planet. Enceladus works the same way, just on a smaller scale. It's a tiny moon, barely 500 kilometers across, but Saturn squeezes it. And Enceladus responds with geysers, plumes of water vapor and ice particles that shoot hundreds of kilometers into space through cracks in the southern polar region. We've flown through those plumes. The Cassini spacecraft sampled them directly, and we found water, salt, organic molecules, silica particles that suggest hydrothermal activity on the ocean floor. Everything you'd need, everything that matters. So here's what we're looking at. Worlds that are cold on the outside but warm on the inside. Worlds where heat comes not from a star but from gravity itself. Worlds where darkness doesn't mean death. It just means a different kind of life. Life that never asked for the sun. Life that never needed it. And if intelligence can emerge in Earth's lightless depths, why not there? Why not in an ocean warmed by the patient, invisible squeeze of a giant planet's gravity? The universe, we're learning, is more generous with its possibilities than we ever imagined. Now we come to something harder to imagine, something that changes everything about how we think of intelligence and civilization. Let's say life does exist in these oceans. Let's say it evolves, becomes complex, develops nervous systems, problem-solving abilities, curiosity. Let's say something down there becomes intelligent, truly intelligent the way we consider ourselves intelligent. What can they do with that intelligence? Because here's the problem. They can never make fire. Fire requires oxygen, fuel, and ignition. You might have oxygen dissolved in water. You might even have combustible materials, organic matter, perhaps hydrocarbons seeping from the ocean floor. But you can't ignite anything underwater. Fire and water are opposites, fundamentally incompatible, and fire is where human civilization begins. We don't think about this much because fire has been with us for so long. Homo erectus was using fire 1.5 million years ago, maybe earlier. We've never existed as a species without it. Fire gave us cooked food, which gave us more calories, which allowed our brains to grow larger. Fire gave us warmth, which let us migrate into cold climates. Fire gave us light, which extended our productive hours beyond sunset. But more than that, fire gave us technology. You can't smelt metal without fire. You can't make ceramics without fire. You can't forge tools, blow glass, create alloys, or generate the high temperatures needed for chemistry as we know it. Every single piece of technology in the modern world, every phone, every computer, every wire, every engine, descends from the moment someone figured out how to make bronze by heating copper and tin together, and that requires temperatures around 950 degrees Celsius. Try reaching that temperature underwater. You can't. The laws of physics won't allow it. So what does an intelligent species do when they can't have fire? They adapt. They innovate within the constraints of their environment. Just like we did, but differently. Let's think about what they can do. They can shape ice. At those pressures and temperatures, ice behaves almost like rock. It can be carved, fractured along specific planes, perhaps even grown in controlled ways. Ice architecture, ice tools, different forms of ice with different properties depending on pressure and temperature. They can use biological materials in ways we never considered. Bone, shell, cartilage. Maybe they learn to cultivate organisms that produce specific structures, living tools, living shelters. We're only beginning to explore bioengineering. Perhaps they've been doing it for millennia, not because they're advanced, but because it's their only option. They can harness pressure. The deeper you go in an ocean, the more pressure increases. At Europa's ocean floor, the pressure might be 3,000 times greater than at the surface. That's a resource. Pressure can shape things, compress things, drive processes we haven't thought of. They can manipulate sound. Water is an incredible medium for acoustic transmission. Sound travels faster and farther in water than in air. Maybe they've developed sonic tools, ways to use focused sound waves to cut, to heat through cavitation, to communicate across vast distances. They might even understand physics and mathematics. Abstract thought doesn't require tools. You don't need fire to comprehend geometry, to recognize patterns, to develop formal logic. Ancient Greek philosophers did much of their work with nothing more than sand and sticks for drawing diagrams. But here's what they cannot do. They cannot access the periodic table the way we have. They cannot work with metals. They cannot create electrical circuits, at least not in any way we'd recognize. They cannot generate high temperatures for experimentation, which means they cannot build radios, cannot build rockets, cannot build anything that would let them reach beyond their ocean, through the ice, into space. Even if they know, somehow intuit or theorize that there's something beyond their world, they have no way to reach it, no way to test that hypothesis. Imagine being intelligent enough to wonder about the universe, but physically incapable of accessing it. Not because you lack curiosity or ingenuity, but because your environment simply doesn't provide the raw materials for that kind of exploration. That's not a failure of intelligence, it's an accident of birthplace. And it raises an uncomfortable question. How much of our own civilization is due to our brilliance, and how much is simply luck? The luck of evolving on a planet with accessible metals, with an oxygen atmosphere, with dry land where fire can burn. We like to think we're special, maybe we're just fortunate. So let's imagine they've overcome these limitations as best they can. Let's imagine a civilization has emerged in these dark oceans. Not human, not like us, but conscious, social. Building something that deserves to be called culture. What does that culture look like? Start with the most basic question. How do they preserve information? We write things down. We carve them in stone, print them on paper, and code them in digital memory. Our entire civilization rests on the ability to externalize knowledge, to put it somewhere outside our own minds where it can persist, be copied, be transmitted across generations. But underwater, everything dissolves or drifts away. You can't write in sand. The currents would erase it within hours. You can't keep books or scrolls. Even if you could create something like paper from biological materials, it would disintegrate. Ink would disperse into the water before it dried. So maybe they don't write at all. Maybe they remember. There are human cultures that maintained vast bodies of knowledge entirely through oral tradition. The Aboriginal Australians preserved accurate information about coastlines and sea levels from over 10,000 years ago, passed down through stories, generation after generation, without ever writing a word. The Polynesian navigators crossed thousands of miles of open ocean using only memorized star positions, wave patterns, and bird behavior. No maps, no instruments, just knowledge, held in the mind and passed through teaching. So it's possible, but it requires something. It requires community. It requires constant transmission. Knowledge held only in minds must be shared continuously, or it dies with the individual. Perhaps their society is built around this necessity. Perhaps they gather regularly, not occasionally, but as a fundamental pattern of existence, to share knowledge, to sing the histories, to reinforce the collective memory. And maybe song isn't just metaphorical, sound is their primary medium. In water, vocalization carries meaning across distances in ways that visual signals never could. Maybe their culture is literally sung. Complex acoustic patterns that encode information, emotion, identity. Whales do this, in a simpler form. Humpback whales sing songs that can last 20 minutes, with themes and variations, and these songs change over time. They evolve culturally, spreading across populations. That's not instinct, that's learned behaviour, that's tradition. Now imagine something far more sophisticated. Imagine songs that contain mathematical proofs, historical records, philosophical arguments, technical knowledge about hunting or navigation, or the properties of different types of ice. Imagine a society where education means learning to sing the world. And then there's architecture. What does a building look like when you can't pile stone on stone, when you can't forge metal beams, when everything must remain neutrally buoyant or it sinks to the bottom? Perhaps they build with biology, cultivated reefs of organisms that grow in specific patterns, living structures that filter food from the water while also serving as dwellings, as gathering places, as landmarks. We're starting to do this ourselves, growing buildings from mycelium, using bacteria to produce materials. But for them, it wouldn't be experimental. It would be the only way. Or maybe they don't build permanent structures at all. Maybe their architecture is temporary, social, dynamic. Maybe they create spaces by gathering together, by using their own bodies as boundaries and walls. Maybe home isn't a place but a configuration, a pattern of individuals arranged in a certain way. That sounds alien to us. But is it really? When we gather around a campfire, we're creating a temporary architecture of warmth and light and social connection. When it's over, the architecture dissolves, but the memory remains. Perhaps all of their civilization works this way. Not built into the environment, but carried within the community itself. Knowledge in memory, architecture in arrangement, art in performance, nothing permanent, everything living. Which means that if such a civilization ended, if they went extinct, if something disrupted their ocean, there would be almost no trace of them, no ruins, no artifacts, no fossils of their technology, because their technology was themselves. They would vanish as completely as a song when the last singer dies, and maybe that's happened already. Maybe there have been civilizations in Europa's ocean. Maybe there are civilizations there now. Maybe they've risen and fallen multiple times over millions of years, and each time the ocean has erased every trace. On Earth, we can dig up the past. We can find pottery shards from 5,000 years ago, tools from 100,000 years ago, fossils from hundreds of millions of years ago. But in an ocean world, the past dissolves. Only the present remains. Only what is actively remembered and sung. That's a fundamentally different relationship with time, with history, with existence itself. And it's beautiful in its way. Fragile, yes. Vulnerable, but beautiful. Let's sit with something difficult now. Something that might feel deeply lonely even from across the solar system. Imagine you're intelligent. Imagine you're curious. Imagine you have language, culture, maybe even philosophy. And imagine that one question keeps arising. The same question that has haunted humans for millennia. Are we alone? You ask this question. Your people have probably always asked it. It's a natural question for any conscious mind. When you become aware of yourself, you start to wonder about others. Not just the others you know, the ones swimming beside you, but others out there, somewhere beyond your immediate experience. But here's the unbearable part. You have no way to answer it. On Earth, we can look up. We can see the moon and know immediately that other places exist. We can see the planets moving against the background stars and understand that we're part of something larger. We can see the Milky Way stretched across the summer sky and grasp, even without telescopes, that the universe is vast. That visible vastness is what drove us to explore. It's what made us build better and better tools for seeing farther. Telescopes, radio dishes, space probes. Every step in our exploration of the cosmos began with the simple fact that we could see there was something out there to explore. But in an ocean sealed by ice, there is no out there that you can see. You might swim to the ice ceiling, you might touch it, map it, understand that it's a boundary, but you can't see through it. Ice isn't transparent at those thicknesses, especially ice that's been fractured and refrozen countless times, filled with brine pockets and stress fractures. And even if you could somehow see through it, even if you could reach a place where the ice was thin and clear, what would you see beyond it? Vacuum. Darkness. Maybe Jupiter's faint reflected light. But you'd have no context for what you were looking at. You might develop science. You might understand chemistry, pressure, temperature, the behavior of water and ice. You might even develop a sophisticated understanding of mathematics and logic. But without the ability to observe the universe, whole branches of science would be impossible. No astronomy. You can't study objects you can't detect. No understanding of the solar system or of orbits, or of gravity on a cosmic scale. You'd understand local gravity. Things sink. Pressure increases with depth. But you wouldn't know about planets, moons, stars. No concept of the electromagnetic spectrum beyond what you could sense directly. Perhaps you'd understand sound, pressure waves, maybe even electrical fields. But light? Light as a thing that travels? As a way to see distant objects? Why would you even develop that concept? And here's the cruelest part. You might be right there. You might be living on a moon that's part of a system with dozens of other moons. You might be orbiting a planet that's orbiting a star that's part of a galaxy with hundreds of billions of other stars. The universe might be teeming with life, with intelligence, with civilizations looking up and wondering the same thing you're wondering. But you cannot know this. Not with any certainty. Not with evidence. You can theorize. You can philosophize. You can create myths about the beyond or the upper realm, or whatever your language would call it. Some of your philosophers might argue that your ocean can't be all that exists, that there must be something more. And they'd be right. They'd be absolutely right. But they'd have no way to prove it. And perhaps worse, they'd have no way to act on it even if they believed it completely. We sometimes think about the tragedy of civilizations that destroy themselves, or that never develop technology, or that go extinct before they can reach the stars. But this is a different kind of tragedy. This is a civilization that could be brilliant, curious, sophisticated, and still, fundamentally isolated, not by choice or by failure, but by the simple fact of where they exist. They're not alone in the universe, they're just alone in their ability to know they're not alone, and there's something almost unbearably sad about that. A loneliness that can't be solved, because you can't solve a problem you can't fully articulate or investigate. We look up and wonder if anyone's out there. Maybe on a moon of Jupiter something looks up at endless ice and wonders the same thing, and maybe we'll never meet. Not because we're too far apart in space, but because we're separated by barriers that can't be crossed from their side, only from ours. Let's talk about Europa specifically now. Let's look at what we know, what we've seen, what we've measured from across hundreds of millions of kilometers. Europa is the 6th closest moon to Jupiter and the 4th largest, about 3,100 kilometers across, slightly smaller than our own moon. If you placed it next to Earth, it would look small and fragile, a pale sphere against the blue and green of our world. But don't let the size fool you. Europa is one of the most fascinating objects in our solar system. The first thing you'd notice, the first thing the Voyager probes noticed back in 1979, is how smooth it is. No mountains, no large craters, just ice, stretching in every direction, reflecting Jupiter's light with an eerie brightness. The surface is young. We can tell by the lack of craters. In our solar system, Older surfaces are more heavily cratered. They've had more time to accumulate impacts from asteroids and comets, but Europa's surface looks fresh. Geologically speaking, it might only be 40 to 90 million years old, which means something is resurfacing it. Something is erasing the old and laying down the new. Most likely water from below seeping up through cracks, then freezing in the cold vacuum, filling in the scars. The ice is healing itself, constantly, slowly. But look closer, and you'll see Europa isn't smooth at all. It's covered in lines, cracks, fractures that crisscross the surface in chaotic patterns, like a windshield hit by a stone, like broken glass held together by surface tension. Some of these cracks are dark, reddish-brown, almost rust-coloured. We think that colour comes from salts and minerals that were carried up from the ocean below, then altered by Jupiter's intense radiation. Sulfur compounds, maybe. Magnesium sulfate. We're not entirely sure, but those coloured cracks are important. They're telling us that there's communication between the surface and the depths, that the ocean isn't completely sealed off, that material moves up through the ice, reaching towards space. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, gave us our best look at Europa. It flew by the moon multiple times, mapping the surface, measuring the magnetic field, analysing the thin atmosphere. And Galileo found something crucial. Europa has an induced magnetic field. That means there's something conductive beneath the ice, something liquid, something salty, something that responds to Jupiter's powerful magnetic field as Europa passes through it. That's one of our strongest pieces of evidence for the ocean. Not speculation, not wishful thinking, actual magnetic data that only makes sense if there's a global layer of salty, liquid water beneath the ice. We've also measured how Europa flexes. As it orbits Jupiter, the tidal forces squeeze and release the moon, and by watching how the surface moves, we can infer what's beneath it. A solid body would flex differently than one with a liquid layer. Europa flexes like something with an ocean inside. Then there are the plumes. Maybe. We're not certain yet. Some observations from Hubble suggest there might be water vapour erupting from the surface occasionally. Geysers, like the ones on Enceladus, but less frequent, less predictable. If those plumes are real, they'd give us a way to sample the ocean without even landing. We could fly through them, collect the ice particles and vapour, analyse them for chemistry, for organic molecules, for any biosignatures, but we're getting ahead of ourselves. Right now, Europa is still mostly mystery. We have measurements, models, educated guesses. We know there's an ocean. We're confident about that, but we don't know how thick the ice really is. We don't know exactly how warm the ocean is, or what the chemistry is like, or whether there are hydrothermal vents on the seafloor. We don't know if anything lives there. But we're going back. NASA's Europa Clipper launched in 2024 and it's on its way. Now, it'll arrive in 2030 and spend years studying Europa in detail, mapping the ice thickness, analysing the surface composition, measuring the ocean's depth and salinity, looking for the best places to eventually land. And ESA's JUICE mission, the Jupiter Icy Moons Explorer, will study Europa along with Ganymede and Callisto. We're building the case, gathering the data, preparing for the moment when we might actually drill through that ice and lower a probe into the darkness below. It hasn't happened yet, but we're getting closer, and Europa waits, silent and patient, keeping its secrets beneath kilometres of frozen time. For now, we can only look, only wonder, only imagine what might be swimming in that dark water so close to us and yet so utterly out of reach. Now let's travel outward, past the asteroid belt, past Jupiter, all the way to Saturn, that beautiful ringed giant floating in the outer solar system. And there, among Saturn's 60-some moons, there's a small one, a tiny one really, so small you might overlook it entirely if you didn't know what you were looking for. Enceladus, just 504 kilometres across. You could fit it inside the borders of Texas with room to spare. It's 1/7 the diameter of our moon, a snowball by cosmic standards. And it shouldn't be interesting. objects that small should be geologically dead, frozen solid billions of years ago, with nothing happening on or beneath their surfaces, no heat, no activity, just ancient ice, cratered and still. But Enceladus didn't follow the script. In 2005, the Cassini spacecraft flew past Enceladus on a routine observation pass, and the instruments detected something unexpected: a cloud, a plume of material erupting from the moon's south polar region, shooting hundreds of kilometers into space, water vapor, ice particles, spraying out like a cosmic fountain. At first, the team thought it might be an error, but Cassini went back, again and again, and every time the plumes were there. Not continuous, not constant, but persistent. Real. Enceladus, this tiny frozen moon, was active, is active. Right now, as you're listening to this, material from its subsurface ocean is being launched into space. Let's think about what that means. The plumes emerge from a region scientists started calling the tiger stripes. 4 long fractures in the south polar terrain, each about 130 kilometers long and warmer than the surrounding ice. Not warm by our standards, but warm enough that we can detect the heat signature from space. These aren't just cracks, they're active vents, fissures that reach down through the ice shell into the ocean below, and the pressure, the tidal pressure from Saturn squeezing Enceladus, forces water up through these openings and out into space. Some of the ice particles fall back down, creating a fine snow on the surface, but some escape entirely, feeding Saturn's E-ring, a faint diffuse ring made almost entirely of ice from Enceladus. The moon is literally creating one of Saturn's rings just by existing, just by venting its ocean into the void. And here's where it gets remarkable. Cassini flew through those plumes, directly through them, sampling the material with its instruments, and what it found changed everything we thought we knew about Enceladus. Water, yes, but not just water, salt, sodium chloride, table salt, which means the ocean is salty, similar to Earth's oceans. That's important because it tells us about the chemistry, about the interaction between water and the rocky core below. Silica. Tiny particles of silicon dioxide. On Earth, this forms when hot water interacts with rock. Specifically, when water at temperatures above 90 degrees Celsius dissolves minerals from rocky surfaces, which strongly suggests hydrothermal vents on Enceladus's seafloor, and organic molecules, complex carbon-based compounds, methane, ethane, propane, even larger molecules, some with dozens of atoms, the building blocks that life uses, not life itself. Let's be clear about that. These are ingredients, not organisms, but they're the right ingredients. Everything you'd need for chemistry to become biochemistry. Cassini also detected molecular hydrogen in the plumes, and hydrogen is key. On Earth, certain microbes survive by combining hydrogen with carbon dioxide, extracting energy from that chemical reaction. It's called methanogenesis, and it's one of the most ancient metabolic pathways we know. If there are hydrothermal vents on Enceladus, and the silica particles strongly suggest there are, then hydrogen would be produced naturally as hot water reacts with the rocky core. And where there's hydrogen, where there's carbon dioxide, where there's liquid water, you have an environment where life could exist, not does exist, could exist. There's a difference, and it matters. But think about what we're saying. A moon the size of a small state, orbiting a planet 1 billion kilometers from the sun, is actively telling us about its subsurface ocean. It's sending samples directly to us. We don't even need to land. We don't need to drill. We just need to fly through the plumes with the right instruments and listen to what the moon is saying. Enceladus is shouting into space. It's been shouting for millions of years, probably longer, and we finally heard it. And now we're listening very, very carefully, because if there's life in that ocean, simple life, microbial life, anything at all, Enceladus might be giving us pieces of it every time it exhales into the void. All we have to do is look. Let's imagine again. Let's return to that dark ocean and think about what communication means there. On Earth, for most of our history, we communicated by sound, speech, song, drums, bells ringing across valleys. We used what the medium gave us, air, which carries vibrations reasonably well over short distances. But then we discovered we could communicate with light. Fire signals on hilltops, lanterns in towers, flags. Eventually the telegraph, radio, fibre optics. Most of our modern long-distance communication is fundamentally about manipulating electromagnetic radiation. Light is fast, light is precise, light can carry enormous amounts of information, and in a vacuum, in the space between worlds, light is how we speak to our spacecraft, how we'd speak to other civilizations if we found them. But light doesn't work well underwater. It scatters, it gets absorbed. Even in Earth's clearest ocean water, light fades to nothing within a few hundred meters. So if there's intelligence in Europa's ocean, they're not using light to communicate across distances. They're using something else. Most likely they're using sound. Water is an extraordinary medium for acoustic communication. Sound travels about 4 times faster in water than in air, roughly 1,500 meters per second. And it travels farther, much farther, especially at certain frequencies that can propagate for hundreds or even thousands of kilometers. Whales know this. A blue whale's call can travel across entire ocean basins. Fin whales produce infrasound, frequencies below what humans can hear, that can potentially circle the entire planet underwater, bouncing off the seafloor and the surface, carrying for thousands upon thousands of kilometers. So imagine what a technological society could do with sound if sound was their primary communication medium. They might have developed acoustic engineering to a degree we've never considered. Ways to focus sound into tight beams like acoustic lasers. Ways to modulate frequencies to carry complex information. Not just simple messages, but detailed data, mathematics, images translated into acoustic patterns. They might have relay stations throughout their ocean, biological or constructed, that receive, amplify, and retransmit signals, creating a communication network spanning their entire world. They might use different frequency ranges for different purposes. Low frequencies for long-distance communication that can travel across the ocean. High frequencies for short-range, high-bandwidth data transfer. Ultrasound for precise echolocation and detailed mapping. And they might have developed acoustic memory storage, ways to encode information into standing wave patterns, into resonant structures, into systems that preserve acoustic data the way we preserve magnetic or optical data. We think of writing as visual, marks on a surface. But what if writing could be acoustic? Patterns stored in crystal structures or in the resonant cavities of biological or grown materials, readable by sonar? They might map their entire world this way. Not by seeing it, but by listening to it. Every feature of their ocean would have an acoustic signature. The ice ceiling above, its thickness, its texture, its stress patterns. The rocky floor below, its composition, its topography, its thermal vents, the currents and pressure zones, the distribution of minerals and organic matter. They could create maps more detailed than any visual map we've made. Because sound can penetrate, can reveal internal structure, can detect things that light would simply bounce off of. And perhaps most beautifully, their astronomy, such as it is, would be acoustic too. They can't see stars, but they could hear their world. They could map the tidal flexing of their moon, notice the patterns of stress and release in the ice, and from those patterns, potentially infer that something massive is pulling on them. They might not know it's Jupiter. They might not know it's a planet, but they could know that there's a source of periodic gravitational influence. They could measure it, predict it, build a mathematical model of it. They could develop orbital mechanics without ever seeing an orbit. They could understand that they're not alone, not in the sense of other civilizations, but in the sense that their world is part of a system, influenced by forces from beyond their ocean. And maybe that's enough Maybe that's a kind of astronomy, different from ours but equally valid, equally sophisticated, a civilization that maps the universe by its gravitational whispers rather than its light, a science built on listening rather than looking. It's not what we do, but it's not worse, it's just different. Another way of knowing, another way of reaching toward understanding with whatever tools your environment provides. And in the darkness, in the eternal ocean, perhaps sound becomes more than communication. Perhaps it becomes art, history, identity. Perhaps it becomes everything. Perhaps they don't need to see the stars. Perhaps they've learned to hear the universe instead, and perhaps that's just as profound. Here's something we sometimes forget. Mathematics doesn't require eyes. It doesn't require fire or tools or laboratories. It doesn't require telescopes or particle accelerators or anything external at all. Mathematics is abstract thought, pure pattern recognition, the logic of relationships and structures, and if there's intelligence in those dark oceans, there's no reason they couldn't discover it too. Let's start with the simplest things. Counting. 1 creature, 2 creatures, 3. 1 thermal vent, 2 vents, 3. The concept of quantity exists regardless of what you're counting or how you perceive it. Then patterns, rhythms. The tidal flexing happens in cycles, predictable cycles. Something squeezes, then releases, then squeezes again. That's a pattern, and patterns can be analysed, predicted, understood. From there you get arithmetic, addition, subtraction. If I have 3 fish and I catch 2 more, I have 5. If our group has 7 members and 3 leave, 4 remain. This isn't human mathematics. This is just mathematics. Universal. Geometry might follow, not from drawing shapes in sand, but from navigating 3-dimensional space. An ocean is fundamentally geometric. Straight lines between points, angles, distances, the shortest path between 2 locations. Maybe they develop an intuitive understanding of spherical geometry by navigating their spherical world. Every long-distance journey on a sphere naturally follows curved paths, great circles. They'd feel this in their movement, understand it in their navigation. Pressure gradients would give them calculus in a way. The rate of change of pressure with depth. The way temperature changes as you approach a thermal vent. These are continuous functions, and observing them could lead to understanding rates of change, slopes, derivatives, even without formal notation. And then there's acoustics, which is deeply mathematical, harmonics, resonance, wave interference, if they're using sound for everything, communication, navigation, sensing their environment, they'd necessarily develop sophisticated mathematical models of wave behavior. They might discover prime numbers, patterns in sequences. The Fibonacci sequence appears in growth patterns, in spiral structures that might exist in biological forms, even in their ocean. They might develop logic, if then reasoning, proofs by contradiction. The structure of argument itself, which doesn't require any sensory input at all, just the ability to hold and manipulate abstract concepts. And here's where it gets profound. They might figure out things about the universe that we've figured out. Not from observation, but from pure thought. Symmetry principles, conservation laws, the idea that certain quantities remain constant even as systems change. You can derive a lot of physics from symmetry alone, without ever conducting an experiment. They might reason their way to understanding that their world is curved, is finite but unbounded. That if you travel far enough in one direction, you return to where you started. They might develop theories about what lies beyond their ocean, not from seeing it, but from noticing inconsistencies, gaps in their models, things that only make sense if there's something more. Ancient Greek philosophers figured out that the Earth was round without leaving the Mediterranean. Eratosthenes calculated its circumference using only shadows and geometry. That's pure reasoning applied to limited observations. An ocean civilization could do the same. They could build elaborate mathematical frameworks describing reality. their reality, and perhaps even the reality beyond it. And some of their mathematics would match ours exactly, because mathematics isn't invented, it's discovered. It exists independent of who's discovering it. A circle's ratio of circumference to diameter is pi, whether you're human or not, whether you can see or not, whether you live under ice or under stars. Some truths are universal, and maybe that's the most hopeful thing, that even across impossible barriers separated by ice and vacuum and circumstance, two intelligent species could discover the same truths, different paths, same destination, mathematics as a kind of common language, even if we never speak it to each other. Let's think about the dreamers, the ones who wonder about the edge. In every human culture, there have been people who looked at boundaries and asked what lay beyond them. The horizon, the mountains, the ocean, the sky. These are the explorers, the mystics, the restless minds who couldn't accept that the known world was all there was. Would it be different in an ocean beneath ice? Maybe some of them swim upward, as far as they can go, until they touch the ceiling, that hard, cold boundary that doesn't yield, doesn't break, doesn't open, and maybe they press against it. Not just once, but repeatedly. They map it. They notice that it's not uniform, that there are places where it's smoother, places where it's rough, places where it groans and cracks with stress. Maybe they notice that the pressure changes aren't quite symmetrical, that there's a rhythm to the flexing, but also anomalies, variations that suggest forces from beyond pulling and pushing in patterns they can't quite see. What do they make of this? Perhaps they develop myths, stories about the upper realm, a place that can't be reached but must exist because the ice itself exists, and something must lie beyond it. Maybe their creation stories involve the ice. Perhaps they believe they were born from it, that their ancestors somehow came through it from somewhere else. Or perhaps they believe the ice is a barrier placed deliberately, a wall between worlds. There might be religious movements built around the ice, sects that believe swimming upward is sacred, that touching the ceiling is a form of prayer. Others who believe the ice should never be touched, that it's forbidden, that it separates them from something dangerous or divine. And there would be scientists too, thinkers who try to understand the ice not spiritually but materially, who measure its thickness acoustically, who study its properties, who develop theories about what it's made of and why it exists. Some of them might reason correctly. They might figure out that the ice is frozen water, their water transformed by extreme cold. They might deduce that beyond the ice, conditions must be radically different, colder, perhaps airless, perhaps hostile to life as they know it. But they couldn't know for certain. They'd be theorizing in the dark, quite literally. And maybe there are poets among them, ones who compose songs about the unreachable, about the ache of knowing there's a boundary, but not knowing what lies beyond it, about the feeling of pressing upward towards something you can never touch, never cross. Maybe they have a word, a concept we don't have, for the specific loneliness of being enclosed. Not claustrophobia, which is fear, but something gentler, a wistful awareness of containment, the sadness of a finite world. Or maybe they don't experience it as sadness at all. Maybe most of them never think about it. The ice is simply the top of the world, the way the seafloor is the bottom. It's just reality. No more troubling than the fact that we can't fly unaided or breathe underwater. But there would be some, there are always some, who can't let it go, who dream about the beyond, who create art about impossible journeys, who dedicate their lives to understanding the boundary, even if they can never cross it. Every civilization has its dreamers, its people who stare at walls and imagine doors, and walls don't have to be metaphorical to be real. Let's imagine the impossible. Let's imagine we actually go there, not just orbit Europa or fly through Enceladus's plumes. Let's imagine we land, we drill through the ice, we lower a probe, a submersible, equipped with lights and cameras and sensors, down through kilometers of frozen darkness until finally it breaks through into liquid water, and we explore that ocean. For a long time, we'd probably find nothing, just water, darkness, maybe some chemistry, maybe some simple organic molecules drifting in the currents. We'd be thrilled with that. That alone would be revolutionary. But let's imagine we find more. Let's imagine we find life, and not just microbial life, but something complex, something moving with purpose, something that notices us. What would that moment be like? For us, it would be transcendent. The discovery of a lifetime, of 1,000 lifetimes, proof that life exists beyond Earth, that we're not alone in the universe. We try to communicate, probably. Flashlights in patterns, emit sounds at various frequencies, try to establish that we're intelligent, that we come in peace, that we mean no harm. But from their perspective, if they're intelligent, if they're watching, what would they think? They've never seen anything like us, never seen a manufactured object, never conceived that something could come from beyond the ice. Their entire understanding of reality has been built on the assumption that their ocean is all there is. And suddenly there's this thing, this inexplicable thing. Hard surfaces where nothing should be hard, lights in the darkness, and they've never seen light like this, artificial and steady and bright, sounds that don't match any biological pattern they know. It would be beyond alien. It would be metaphysically disturbing. Like if something materialized in your living room that violated every law of physics you understood. Not just strange, impossible. Would they be curious, frightened, aggressive, reverent? We don't know. We can't know, because we have no framework for understanding a mind that evolved in total isolation, with no concept of elsewhere. Maybe they'd try to communicate back. Maybe they'd probe us with sonar, try to understand what we're made of, how we move, what we are. Maybe some of them would realize, the brilliant ones, the theoretical thinkers, that we're proof of the beyond, that their myths and theories were right, that there is something past the ice. But how would you explain Earth to them? How would you explain that we come from a place with air and fire and stars, that we can see across vast distances, that our world is so different from theirs that we might as well be from different universes? How do you communicate the concept of sun to something that's never seen light? How do you explain sky when up has always meant ice? And here's the heartbreaking part. Even if we could communicate, even if we could establish some form of dialogue, what then? We can leave. We can return to our world of light and air and open space. They can't. They're still trapped, still contained by kilometers of ice, by the physics of their world. Meeting us doesn't free them. It just makes them aware, possibly for the first time, of everything they can never reach. Is that a gift? Or is that cruelty? We'd arrive as proof that they're not alone, but also as proof that they're imprisoned. Let's sit with both truths, because they're both real, and neither cancels out the other. The ice is protection, it's shelter, it's the reason life could exist there at all. Without that thick frozen shell, Europa's ocean would have boiled away billions of years ago. The vacuum of space, the radiation from Jupiter, it would strip any exposed water into nothing. The ice is a shield. It keeps the ocean intact. It keeps the pressure stable. It maintains an environment where chemistry can be gentle, where molecules can interact without being torn apart by solar wind or cosmic rays. And it's not just physical protection. The ice also provides stability. On Earth, our surface environment changes dramatically. Ice ages come and go. Continents shift. Asteroid impacts sterilize entire regions. Supervolcanoes erupt. Our biosphere is violent, chaotic, constantly disrupted. But beneath kilometers of ice, the environment is stable, unchanging, the same darkness, the same pressure, the same temperature, for millions or billions of years. Evolution can proceed slowly, carefully, without constant catastrophic resets. If life exists there, it exists because of the ice, not despite it. The ice is what makes it possible, so in that sense these ocean worlds are gifts, perfect cradles for life, protected nurseries where biology can unfold in peace. But if intelligence arises there, if something becomes conscious, curious, capable of wonder, then that same protection becomes a cage, not because the ice is actively hostile, not because it's trying to trap anything, just because it's there, because it does its job too well, because the same properties that protect also isolate, and there's something deeply unfair about that. Not morally unfair, the universe doesn't owe anyone fairness, but unfair in the sense of tragic coincidence. The idea that the very thing that enables your existence also limits what you can ever become. We humans have our own version of this. We're protected by Earth's atmosphere and magnetic field. Without them, we'd be sterilized by radiation. But that same atmosphere makes it incredibly difficult to leave. Every kilogram we want to put into space requires enormous energy to push through the air, to overcome gravity. But at least we can leave. It's hard, it's expensive, it's dangerous. But it's possible. We've done it. We've walked on the moon. We've sent probes beyond the solar system. For a civilization beneath ice, even that might be impossible. Not just difficult, actually impossible. The energy requirements, the technological challenges, the simple physics of drilling up through kilometers of ice from below, with only biological or acoustic tools, it might not be achievable, ever. So you could have a brilliant civilization, sophisticated, philosophical, mathematical, rich with culture and art and meaning, and they could be permanently contained, not because they lack ambition or intelligence, just because of where they were born. Is the universe cruel for creating such places? Or is it generous for creating places where life can exist at all? Maybe both. Maybe neither. Maybe the universe doesn't think in terms of gifts or prisons. It just creates conditions. And sometimes those conditions are contradictory. Sometimes they give with one hand and take away with the other. And we, looking from the outside, can see both truths. We can honour the beauty of these protected oceans, and we can feel the tragedy of the isolation they impose. Both things can be true. Both things are true. And maybe that's just what existence is like. Everywhere. A mixture of possibility and limitation, freedom and constraint. What you're given and what you're denied. For them, it's ice. For us, it's something else. But everyone, everywhere, lives within boundaries they didn't choose. The question is what you do within those boundaries, what you create, what you become, how you find meaning despite, or because, of the limitations you face, and maybe that's enough. Maybe it has to be. We're near the end now. Let's bring this home gently. There's a loneliness we know well, the kind that comes from looking up at the night sky and seeing all that vastness and wondering if anyone else is out there. Wondering if we're the only ones asking questions, the only ones building telescopes and mathematics and meaning. We've been asking this question for as long as we've been human. Probably longer. Are we alone? And we still don't have an answer. We've searched. We've listened. We've sent messages into space. And so far, silence. Just the radio hiss of the cosmos. Just the light of distant stars, indifferent and beautiful. That's our loneliness. The loneliness of reaching outward and finding no one reaching back. But imagine a different kind of loneliness. The loneliness of not being able to reach at all. Somewhere in this solar system, maybe on Europa, maybe on Enceladus, maybe somewhere we haven't even considered, there might be minds. Conscious, curious minds. Minds that wonder and question and dream. And they might experience that same fundamental ache. That same sense of isolation. The same question, are we alone? But they can't look up. They can't see the stars. They can't even conceive of stars, of light travelling across emptiness, of other worlds circling other suns. All they have is ice above and rock below and the ocean in between. That's their entire universe, and within that universe, maybe they're the only ones asking questions, so they wonder, just like we do. But their wondering has no outlet, no possibility of answer. They're contained by their world in a way we aren't. Two kinds of loneliness, separated by circumstance. We're reaching outward, hoping someone will answer. They're sealed inward, unable to reach at all. And the saddest part, the part that sits heavy in the chest, is that we might be close. so close. We might be orbiting the same star, just a few 100 million kilometers apart. Near neighbors by cosmic standards, two forms of intelligence, two communities of wonder, existing in the same moment of universal time, both asking if they're alone, and the answer for both of us is no, you're not alone. We're here. They're there. But we might never connect. The barriers might be too great. Not barriers of distance. We've overcome distance, but barriers of environment, of physics, of the simple, insurmountable fact that some boundaries can't be crossed from both sides. Still, there's something beautiful in the wondering itself, in the reaching, even when you can't touch, in the question, even when you can't hear the answer. Because the impulse to wonder, that's universal. That's what connects us to any other intelligence that might exist, not technology, not language. But the simple fact of consciousness turning toward mystery and asking, what else is there? We look at ice covering an ocean and we wonder what lies beneath it. Maybe something beneath that ice looks at the ceiling and wonders what lives beyond it. And even if we never meet, even if the barriers hold forever, there's still meaning in that parallel wondering, in knowing or believing that somewhere, someone else is asking the same questions you are. You're not alone in your wondering, even if you're alone in your world. And maybe that has to be enough. Maybe that's what consciousness does. It reaches, it wonders, it asks, even when the universe doesn't answer, even when the answer is sealed away beneath ice. Thank you for staying with us tonight, for letting these thoughts drift through the darkness with you. If this quiet journey meant something to you, a like or subscribe would help us continue making these explorations. But there's no pressure. You're welcome here regardless. Rest well, wonder gently, and remember, somewhere in the universe, beneath ice or under stars, other minds are wondering too. We're all reaching toward something, all of us, together and apart. Good night.